Let's say you're given the products of a reaction, which is an alkene or an alkyne, and you're asked what was the initial alkyl halide and what nucleophilic base or anything else did you add to create this product. Now there's actually a very simple algorithm. So if you want to predict the initial reactant, it's going to be wherever the alkene was, you just replace it with a bromine on the more substituted carbon. So that's your initial reactant. And for the nucleophilic base that you used, it will depend on whether that initial alkyl halide is primary. If it's primary, use this. If it's tertiary or secondary, use this, the typical E2. And if your initial actually had a hydroxyl, you would use acid catalyzed reactions. While if somehow you have two halides in the process, depending on what they give you to start with, usually when you have two halides, this will be the process you go through, which is this is a deprotonation part of the alkyne, and then this is a part that turns it into an alkene, but we'll get to that. Okay, let's try a problem. What was the initial reactant? So I redraw it, but now instead of the alkene, I'm putting a bromide or any other halogen on the more substituted carbon. And because this is tertiary, I can say this underwent an Na, ETO, Na. So that's our nucleophile. Okay. The next problem, same thing. I'm just going to replace it. But now, I want to say I'll replace it with a halogen, but because they gave us that we used an acid, that means the initial is going to be a hydroxyl. So that just follows this rule. Here, I will copy it out, but now I'm adding a bromide on the more substituted carbon, and this is a secondary, so I could use ETONA again, but actually in this specific case, you could also use tert-butoxide, and I'll show you why. Tert-butoxide or BuOH as well, they're fine. Okay, so if you use a bulky base like this, it's going to attack the less substituted the hydrogen on the less substituted carbon, which is here. So this is our base, bulky base. Attack this, and then this bond goes on, the nearest carbon, and then bromine goes away. So then that's how you would get this product. Okay, now we have alkynes. So for making alkynes, let's say our product is here. Usually you start with an acetylene. You deprotonate the acetylene by adding this, which makes it an acetylenide ion. Then with the ions, lone pairs, you can then add your R and halogen here, halide here. So then that's how you will combine your alkyne with a longer carbon chain. So that's how you get the product. So let's try an example. So here we know already that we're going to start with an alkyne, and we need to deprotonate it by adding some Na and H2 to give it the lone pairs that it needs to extend its chain of two more carbons, but on the end of the carbon, it's going to be a leaving group. So the bromine's going to go, and yes, so that is, and make sure that this is primary. I'll actually draw it on the arrows here to make it more clear. Make sure what you draw here is a primary thing, because if it's not primary, the reaction will not happen the way you want it to. So these are the steps, very simple once again. Now, what about this? When they ask you to create an alkene that has E or Z stereochemistry, how to synthesize that is you would start with an alkyne, halogenate it, which would take away the pi bonds, but then stop at the alkene by adding a specific catalyst. If you want a cis or a Z alkene, like here, you will use a Lindlar's catalyst. And some of those include P2, which is just Ni2b, Lindlar's catalyst. So that is how you stop that alkyne from halogenating into an alkane. So this will be the last step. And then the rest of the step, we can copy what we already had. So we start with an alkyne. We add this to deprotonate the alkyne. And we want to extend the alkyne. But as you can tell, it's not just a 2-carbon alkyne. There was actually something at the end. So let's just extend this a little bit, just like that. Like that. And now we just have to add the other side here, which has 3 carbons. Yes, 3 carbons. So 1, 2, 3, plus a leaving group, and plus a Lindlar's catalyst, and that's how you get this alkene. So make sure, big takeaways, whenever you draw your alkyne, make sure it is straight. Do not bend it like this. This will help you lose marks on the exam.